Take a good look at these four graphs. Each one is important because each one is basic. Anyone who's been around a while will recognize a linear function, so-called because it makes a straight line. If I add something to the x value, the y value goes up by a corresponding amount. If you've been around a while, you'll recognize a quadratic function. That's with an x squared in it somewhere. And it's called quadratic because if you square something, that makes a square, and a square has four sides. Quadratic. We also have cubic functions, which are a lot like quadratic functions, except where a quadratic has to stay positive. If you square something, it's positive no matter what. A cubic can actually go negative, usually does to the left, and becomes more positive as you go to the right. And then there's the weirdo, the radical function, so-called because it has a square root symbol or a radical symbol. It's weird because it doesn't start forever away on the left like all these other functions do. It starts at a specific point, specifically where what's under the radical becomes positive. And it also doesn't go faster and faster or even at a constant speed up to the top, up to the maximum infinity value. It goes at a decreasing speed towards infinity. At infinity nonetheless, but slowing down as it gets there. Unless you make the x in these functions go negative. Making the function negative turns the graph upside down. That's because now more x, meaning going to the right, makes y more negative, sending the graph down instead of up. We can also move any one of these graphs up or down. It's actually really easy. Just take whatever happened to x, multiplied, squared, cubed, or rooted, and add or subtract something to the result. That plus b makes the result shift up, add up, or minus down by that exact amount. We can also take these representations of our models and move them left or right, but this part's not nearly as obvious. We do it by changing the x, the input value, before the function gets its hands on it. And because we're changing it before the function does its thing, it's kind of like we're fooling the function, giving it shifted data. If we change the x before the function starts messing with it, it moves the graph opposite of the way we think. X plus 3 quantity squared actually moves the graph 3 spaces to the left. Plus moves left. Looking at this cubic function, x minus 4 quantity cubed moves the graph 4 to the right. We'll call these original four functions parent functions, functions without any change to them. Memorize these four because they're actually really common and you need to be able to tell which one's which. Make any changes to them though and they become children. And the changes we make to these parent functions to make them children do the following things. Multiplying the functions makes them steeper, or multiplying by a fraction makes them less steep. Adding something after the function has sort of done its job moves the function up. Subtracting moves the function down. But adding before the function sort of does its thing to the x moves the function to the left. And subtracting before the function gets its hands on it moves it to the right. With a little bit of practice, you'll learn how to recognize any one of these four parent functions and how to predict what's going to happen to those functions when they become children after you've changed them.